So here is another question on thermal expansion. It is given that a glass flask of volume 200 centimeter cube is completely filled with mercury at 20 degrees Celsius. How much mercury will overflow from the flask when the temperature of the system is raised to 100 degrees Celsius? Okay, so let's say this is the glass flask, okay, container, a glass container. So it is given that it is completely filled with mercury, up to the top. Now, when the whole system is heated, that is, the temperature is raised from initial temperature of 20 degrees Celsius to the final temperature of 100 degrees Celsius, thermal expansion will take place. Here, thermal expansion will take place in the glass flask and also in the mercury which is filled in the glass flask. Thermal expansion will happen in both of them. So overflow will take place when the increase in volume of mercury is greater than the increase in volume of the glass flask. Okay, it will not be able to accommodate, the glass flask will not be able to accommodate the increased volume of mercury, and the difference will overflow from the container. That is the logic. Okay, so let us try to figure out that. So here we'll divide this into two parts, for the glass flask and for the mercury. Okay, so first for the glass flask. The initial volume of glass flask is 200 centimeter cube. Okay, then the initial temperature is 20 degrees Celsius. The final temperature is how much? 100 degrees Celsius. And here another thing is given in the question, I think I forgot to mention it, that the coefficient of volume expansion for both the mercury and glass, it is given. For mercury it is 18 into 10 to the power minus 5 per degree Celsius, and for glass it is 1.2 into 10 to the power minus 5 per degree Celsius. Okay, this is the. Now now the gamma value here for the glass flask is equal to how much? 1.2 into 10 to the power minus 5 per degree Celsius. So the increase in volume for the glass flask will be equal to the gamma, the coefficient of volume expansion, the initial volume V0, and the rise in temperature, that is final minus initial temperature. So it is equal to 1.2 into 10 to the power minus 5 into 200 centimeter cube, the volume, and TF minus T0, final minus initial, that is equal to 80. Okay, this much. So it is coming around 0.19 centimeter cube. This is the increase in volume of the glass flask. Okay. Now for the mercury. For the mercury in the glass flask. Now, if you read the question, it is given that the glass flask is completely filled with mercury up to the top. So, completely filled means the initial volume of the mercury is the same as the volume of the glass flask, that is 200 centimeter cube. Everything else is the same. The initial temperature is 20 degrees Celsius. Final temperature is 100 degrees Celsius. The coefficient of volume expansion of mercury, that is equal to 18 into 10 to the power minus 5 per degrees Celsius. So the increase in volume will be the same concept, that is original volume, that is gamma original volume, and rise in temperature. Okay, so it will be equal to 18 into 10 to the power minus 5, that is the gamma for mercury, original volume 200, and rise in temperature 80. So it is coming around 2.88 centimeter cube. Okay, this is the increase in volume of mercury. So see, the increase in volume of mercury is much greater than the increase in volume of the glass flask. Here it is, for glass flask the increase in volume is 0.19 centimeter cube, whereas for mercury it is 2.88 centimeter cube. So increase in volume for mercury is much greater than the increase in volume for the glass flask. So overflow will take place, excess increased volume of mercury which will not be accommodated by the glass flask, it will overflow. So that volume of overflow is equal to the difference between these two, increase in volume of mercury and increase in volume of glass flask. That difference, that is equal to 2.88 centimeter cube minus 0.19 centimeter cube, which is equal to 2.69 centimeter cube. This is the volume of mercury overflow. Okay, this is the volume of mercury overflow. Okay, so this is the result. So here is another question on thermal expansion. It is given to prove that the volume expansion coefficient gamma is equal to minus 1 by rho d rho by dt, where rho is the density, capital T is the temperature, and gamma is the volume expansion coefficient. Okay, so here first what we have to do is the density rho, it is equal to mass by volume. Okay, that we all know, mass per unit volume. So we can write it as mv to the power minus 1, this way. Now if we differentiate both sides with respect to t, which is implicit differentiation, so d rho by dt, it will be equal to as volume is dependent on temperature because of thermal expansion, mass remains the same, so it will be m minus v power minus 2 dV by dt. This. Okay. So now we can express it as minus m by v, okay, then dV by v dt. We can write it in this way, there will be no problem. 1v in the denominator with mass and this dV by v dt. Now here mass by volume is equal to density, this much, and this dB by v dt. So if you recall the basic definition of volumetric expansion, the increase in volume delta V is equal to the volume expansion coefficient gamma, the initial volume V, and the rise in temperature delta T. If we write it in differential form, it will be dV is equal to gamma V dt. So that implies dV by v dt is equal to this gamma. Okay. So this here dB by v dt, that is equal to gamma. Okay. This is minus. So d rho by dt, the derivative of density with respect to temperature is equal to minus of rho, that is density, and the volume expansion coefficient. That implies we can write it as gamma, the volume expansion coefficient, is equal to minus 1 by rho d rho by dt. This. Okay, so we have proved what was asked to prove in the question, that the volume expansion coefficient gamma is equal to minus 1 by rho d rho by dt, where rho is the density, T is the temperature, and gamma is the volume expansion coefficient. So here when we differentiated both sides with respect to temperature, this is d rho by dt, there is no confusion about that. But here we, this differentiation is called as implicit differentiation, where here mass is constant, mass of a substance, that is constant, but here volume has a direct relationship with temperature. Okay, volume of a substance, it can change with respect to temperature, which is volumetric expansion as per this relationship. So here we differentiated volume with respect to temperature and we got this. Okay, using chain rule and the concept of implicit differentiation. So we got m is constant, mass is constant, we got minus v to the power minus 2 dV by dt. Okay, so this is the result.